I'm naming and shaming you. All right, good morning, everyone. Mostly it's morning for most people on. I know Andrew Scoggins, he's in Perth, so good afternoon to him. Welcome to the Industrial Minerals Guideline launch breakfast. And because it is a breakfast, for those of us who are here at the Minerals Council and SAMREC boardroom, apart from the view, the coffee, we want to get some snacks as well. And also for everyone who's here, a printed out copy of the guidelines themselves. I know people do prefer hard copies too, but yes, welcome. I'm the chair, Spiso Siwela, apologies, the chair of the SSC. And since I'm scheduled to talk for 10 minutes, I'll tell you all about the SSC. Thanks for the presentation. And I know some people might still come into the venue here. There was quite some traffic this morning because of the rains, the floods. So just a reminder for people just to be wary of those conditions, which exacerbate conditions, potholes, trees falling, and those sorts of things, bridges collapsing. So that's a brief safety share. Can you share the presentation, please? Google. I'll try not to use up the 10 minutes since we started a bit late, but yes, thanks again for joining us. Next slide, just a bit about what the SAM Code Standards Committee, the SSC, is about. Yes, slide. All right, I'll quickly rush through this. This information is all thanks, no worries. So I mean, the purpose of the SSC is to develop, maintain, administer and to promote the South African mineral codes, collectively the SAM codes, as we all know. So those are the ones right on top there, the SAMREC code, the SAMVAL code, and the SAMAL code. And essentially is to make sure it's relevant and it's effective. We also undertake periodic reviews to make sure that it is still relevant. And there's work that's going to be coming up from the SAMREC side and SAMVAL as well in terms of updates, so look out for that. And again, it's just promoting an awareness and providing training and sessions such as this. We're also represented on the CRIRSCO committee, which is the international umbrella body to ensure international alignment as a recognized professional organization. And then we've got a long-standing association with the GSC of course, where the SAM codes form part of the listing rules, section 12 for mining companies. Next slide, please. All right, and these are the two co-patrons who fund the SSC. So thanks to the GSSA, SIMM, both 130 years this year. So big celebrations on that point too. So without them, we wouldn't host events such as these. Thank you. Next slide. All right, just in terms of initiatives from the SSC side, what's been happening, a lot of the activity people would have seen was around the incorporation of ESG into the SAM codes. So there's been a working group. Andy McDonald was chair of that ESG working group, and is the immediate past chair for the SSC. So yeah, I took over from him and he laid quite a good foundation. And yeah, one of the working groups he was championing is that, and which started in 2021 with an ESG inquisition, seeing whether there's a need. That then led to the updating of Table 1 SAMREC, SAMVAL, and then SAMESC 2.0 guidelines, which were sent out. So that then will lead into now the updating of the codes themselves. Nicole can tell you a bit about that later on. But yeah, those are just some of the initiatives that have been happening from the SAM code side. And at this point, I'd like to thank all the committee members, not just from the SSC, but also the SAMREC committee, SAMVAL, SAMAC committee, and SAMESC committee. Recently, we would have seen the SAMOG code also being updated around the same time. The Industrial Minerals Guidelines went out for public feedback, the reason we are here today. And there's various things. Please look out on the website for various initiatives that we are running. There's been a call to competent persons telling us the number of reports, SAMREC reports they've done. So go to the website for that. While you're on the topic of the website, thanks. Next slide. Yeah, I mean, the website itself, there's various things. There's newsletters, quarterly and monthly newsletters you can find. There's the SAMCodes app. I hope most of you, all of you, have it loaded for both Android and Apple. But there's instructions for Apple on the website. There's free content of previous SAMREC courses that is available for you to view. There's also an SK 1300 forum page, which came out of the event that was held in 2022 initially and 2023 for the implications of the SK 1300 for dual listed, especially those also listed on the GSE plus the NYSE. Thank you. Next slide. And yes, look out for a whole lot of events. This year, the SAMREC code is celebrating its 25th anniversary. So look out for that. That 25th anniversary logo, those are going to be, that's going to be some of the new branding. So look out for that. But apart from that, there's various events which will be celebrating that too. So we've got Steve Rupert's upcoming course in Rustenburg. We've got contributions in Geo Congress where Nicole, Tanya, and I will be presenting around the SAMCodes. And then there was the big event in September. The date has changed, 29th and 30th September, where we'll be celebrating 25 years of the SAMREC code. And there's going to be the whole workshops around GSE reporting and SAMREC and SAMVAL. Rob will also be there and various other people are here. And then from the SAMVAL side, they'll be assisting around the International Mineral Asset Valuation Conference in October. So they'll be hosting that right here in Johannesburg. So those are just things to look out for. Next slide, please. I'm not going to go into this. This you can find in, that's just a summary of the upcoming events where the SAMCodes is concerned. So thank you. Next slide. All right. And I mean, the reason we are here, while we're here, I'd just like to say a few thank yous during this welcome. So firstly, thank you to the SIMM. Thanks, Gugu, Camilla, and Muibone. Muibone was, thanks for bearing with the Industrial Minerals Guidelines Subcommittee. So I'd like to say thanks to her too. I'd like to thank Rob here, who's championing and will be giving us an overview of the guideline. And one thing he insisted on was having these meetings in person, which, so thanks for that, Rob. And yeah, very productive sessions. Andy McDonald's on the other side, as I said, he was co-chair with Rob Barnett from the Industrial Minerals Guideline, the guy who threw everyone under the bus and had a good idea. So thanks, Nomzane, for your contributions. Nicole from the SAMREC committee, the SAMREC committee chair, who I'll hand over to shortly for all the hard work there. There's the other Andrew I forgot is Scoggs in Perth there. I think he's on at the moment, but thanks for joining and thanks for your input as well. The rest of the committee too, you know, various representatives, which Nicole and Rob will go into. And lastly, again, sponsors. You know, we've got annual sponsors, the co-patrons fund the SSC, but we've also got sponsors who sponsor the SAMCodes app. You can read about them in the newsletter. So we'd like to appreciate them too, because without them, we wouldn't be able first to host such events or even keep the SAMCodes app running. And on that note, sorry, sponsors, we are looking for sponsorships. So there are pamphlets there, sponsorship pamphlets. There are printed out copies of the Industrial Minerals Guidelines, as I mentioned. And for us in the building here, we've also got tea and some snacks too. But thank you. I'll hand over now to Nicole, who will give us a bit about the need for this guideline. Thank you. And thanks for everyone who's here in person, most importantly. So, and online too. Nicole?
Thanks, Sifiso. Okay, you can go good. Thanks, everyone. So I would just like to briefly touch on, why we decided to put together this guideline. At the end of 2023, the need for a standalone guideline to guide the disclosure and reporting of industrial minerals was proposed by the SSC and the McDonald, as there was a gap that was identified. I had, in conversation with Annelie at the JSE, she had mentioned that she had numerous queries from companies that had requested assistance in terms of reporting of these minerals. So at the time, there was no sort of specific guidance on industrial minerals. The guidelines that we do have currently is the SAM ESG guideline, the Diamond guideline, and then the SANS coal guideline and reporting of coal resources and reserves. But I'd like to stress, and I did have this conversation in the committee meeting last week as well, that it's important to note that these guidelines are not part of the SAM codes, and compliance with them is not obligatory. You don't have to comply with what is in the guideline. They are supplements to the codes, and they are provided by the various committees to give additional guidance in addition to what is then in the codes themselves. There are specific references to these guidelines in the codes, and you can then, as the CP, use those guidelines when putting together your report. So I think it's very important that I just upfront put that as up the front comment. Thank you, Gugu. So looking at the existence of industrial minerals in the code as in its current form, just where it specifies industrial minerals, there's a small section in clause 73 that briefly covers the reporting of industrial minerals, and there is some guidance. And it categorically says that if the minerals satisfy clauses 5 and 6, 5 being that they are solid minerals and 6 being that they are considered in table 1, then they would be seen as industrial minerals, and you can continue to report them as such. There are comments in the specific clause, and you can go and read it. I've just put a screenshot here that sets industrial minerals apart from other commodities and deposit types. And those specifics, Rob will go into detail when he does take you through the guideline itself. Thank you, Gugu. Then in terms of Table 1, Section 12 of Table 1 provides guidance for the reporting of industrial minerals. It does require the CP to take cognizance of Sections 1 through 9 to consult those if it's applicable to their report. And specific to this Table 1, if you read through this in the SAMREC code, it's very generic. There are no specific guidelines. However, in the guideline, Table 1 has now been expanded upon, and there is a lot more information and guidance in that expansion. As I mentioned, the Table 1 in the guideline is just that additional guidance, but in terms of what is compulsory in a report, what is in SAMREC Table 1 stands as it currently is in the form. Thank you, Gugu. So in terms of a timeline, just briefly a timeline of how this was set off. We had our first kickoff meeting in February at these offices, and Rob there graciously accepted the role of chair to drive, or he was forced into it. Let's put it that way. So I thought I would make it that he graciously accepted. From that session, and it was a very interesting discussion for me because, I will admit I'm not too au fait with industrial minerals myself. From that discussion, a really great discussion, Andy Mack then put together the terms of reference for the subcommittee to work through in the process of them putting together the guideline. And something that was a benefit to us was, given the existence of the CRIRSCO appendices and the CIM's guidelines, we could use that as a base, and we didn't have to start from scratch. Naturally, we had to make it specific to our context, which is what Rob and his team had done. And we envisaged that it would take a period of 12 months, and it's pretty much slapping on the 12 months. So it's really great that it's been a good process within 12 months to get this wrapped up. As I mentioned, we had a meeting in November about, this was sort of when the first draft had come out with the committee. There was a request put out to the public for comment, which was received by the committee, and they then addressed those comments. And in our last February SAMREC committee meeting, there were a few queries, but the queries were mostly just questions for clarity. There was nothing major in terms of changes to the guideline that was proposed. And nothing, would halt the acceptance of the guideline. So it was well received. Thank you. As I mentioned, these were the two source documents that were drawn on extensively when the guidelines were put together. Thank you. Next one. So in terms of the objectives of the guideline, industrial minerals, as we know, have very specific requirements that are quite different to hard rock deposits. It's not just grade and density as you would with a normal deposit typically. There are many other parameters that are required to declare a resource, the mineral type, the product use, application of the minerals. So it was a different base that they had to start with to put the guideline together. The request was that all the terminology remain consistent within the guideline as it appears in the codes, and that a glossary would be required where there are no definitions in the codes themselves. And it was requested that the committee attempt to give mineral minimum specifications on the raw materials for each product, as well as the test work investigations. Rob will go through that. It's very difficult in this context to do that, so hence why I put their attempt to. And then also give specifications for different grades of the products, how the prices relate to an RPEE perspective. And then any aspects related to the processing methods, anything on the finished product, as well as their impact then on ESG within that environment. So those were the main objectives that we set out when we looked at putting this together. Thank you, Gugu. So, that's sort of just wrapping it up from me, the need for the industrial minerals and the process that we followed. Rob will take you through a bit more detail in the guideline itself. From me, I just want to thank Rob and his subcommittee and everybody that had input into putting together this important piece of work. And then to Sifiso and Andy and the SSC for all their guidance through the process and editing and reading and all of that. So thank you to you guys for all of that, for putting this together. Thank you.
Yeah, it's done. To Rob's on.
Okay, thank you for the introductions. Not quite sure we fulfilled all of the requirements. I've taken extracts from the document, but please don't copy these or take photographs of them because I've changed them. Read the document for the genuine thing. But yeah, all right, this is a little bit of what Nicole was talking about. Yes, we use the Canadian, the CIM guidelines, which are excellent. We also use the CRIRSCO guidelines, which are also excellent. I would advise, if you're interested in this thing, to read those as well. Thanks. Next slide. This is the committee. I'd like to mention special names. First of all, Andy MacDonald from SRK. He really produced 80 to 90% of the document by combining the CIM and the CRIRSCO guidelines into one composite document that we could then work on to edit. And the editing was mainly done by Dr. Andrew Scoggins, who is a South African geologist, but now based in Perth, who's, you can say, of international for industrial minerals. What's his name? He helped a lot, and with myself, and we made various amendments to the document. We added some tables at the end, which we hope will be useful as well. But Andy, as I say, did a stupendous job in putting the basics of the document together. Other members came in with comments, etc., etc. Thanks. Okay, next slide. All right. What is an industrial mineral? You can argue about it, but it's basically non-metal, non-fuel or a mineral that is directly used. In other words, you don't extract an element out of it, you use it as it is. But when I say as it is, it can go through quite detailed processing to get it to the final stage. If you take a kaolin, it goes through magnetic separations, bleaching, and all sorts of things. If you take limestone, like the cooler limestone, they float the graphite out. Okay, so it's not unprocessed, but it's still a limestone when it's used, or still a kaolin when it's used by the industry concerned. A classic saying is 2.3, a quote. Without a market, an industrial mineral deposit is merely a geological curiosity. So simply put, no market demand equals no mineral development equals no mineral trade. The market is absolutely key to industrial minerals. It's not an infinite market like gold has. When I say infinite, I mean there's no such thing as an infinite market. But gold guys really don't have to market gold. Copper, you don't, well, there are different grades of copper. Okay, so it gets a little bit complicated. I'm being oversimplistic. But nevertheless, but with industrial minerals, the market is key. Will the market accept what you're going to produce? And different industrial minerals, even if it's the same, if in 2 different kaolins, 2 different bentonites, etc., can be very different. So market, do you have a market from the day one you start thinking about industrial minerals? Do you have a market? And yes, okay, we give a list of common minerals later on. Next slide, thanks. All right, again, key considerations: markets, product specifications. What are the product specifications? Product development. Now, all right, let's go first to the product specifications. Those can vary. They can vary from country to country. They can vary from company to company. If you go to glass, the raw material specifications for flat glass will be different to container glass. If you want to supply feldspar or something else to the flat glass factory, which is in Springs, their specs are different. If you go to another country, their specs will be different because glass ends up as a chemical mix. And if you've got a very high grade sand, you can afford to be a little bit lenient on your feldspar in terms of iron thing. All right. So I'm just trying to give an example of the complexity of specifications. Product development, you have to work through your potential customers and do test work. It's right from the start, from small sample scale to bench sample scales to pilot plant scales, and sometimes even operating plant scales. So now a lot of this is confidential. But a competent person needs to have sight of these reports and it's best actually for the competent person to meet the technical people in the markets concerned. Peter over there, who's the best industrial mineral geologist you'll ever meet, did that. He went to the factories and talked to the people concerned. Okay. And with industrial minerals, it's not like a gold mine or a platinum mine where you end up with a big table all doing a feasibility study and you've got something like 12 engineers all around the table. Often it's you. And you can maybe get some advice from A, B, and C, but it's you. All right. Okay. But it's confidential. So you have to sign confidentiality agreements, but you need to verify. You can't take as given what the guys are saying. Yeah, okay, next slide, please. Again, I'm going to hammer on this. This is the main thing that we wanted to emphasize, was bringing in the market as market segments. Let's take limestone, which is the common industrial mineral used. Are you going to supply the cement industry, the lime industry? All right, the agricultural limestone, well, it's called agricultural lime, but it's agricultural limestone. Are you going to supply aggregate? Are you going to supply the high-grade, very white fillers for paper, paint, and plastic, 3 Ps. Okay, very different markets, very different specifications. And so you need to be aware of the project. What market are they looking at? And each one is very, very different. Now, agricultural lime is the cheapest one, but again, from specifications, they have regulated specifications because it's involved in agriculture. So it's not like a company can make up its own specs. Okay, those are regulated. But another ones like cement, different cement companies will have slightly different specifications. Okay, okay, location. Where is the deposit located? Peter over there knows of some very high quality limestone in the Northern Cape, you know, but it's just miles from anywhere. All right. On the other hand, people did mine dolomite up in Namibia and bought it successfully as a cheap substitute for the cheaper cooler grades down here. And they did that by doing a deal with the transporters, because stuff goes from here to Namibia, the trucks come back empty. So the trucks charge for the load in that way. Load it there, okay, it's empty back. They were able to do a deal where they said, this is what we can afford to pay for transport. And the transporters had beefed up their margin a little bit, so they did it. So, okay, location. You have to think, you know, be aware of the sort of complexities and be quick on your feet as to what you can do. All right, market size. Now, this is a problem that we have in South Africa in terms of because our markets are small. Okay, and there's not a lot of industrial minerals that you can export. Right, obviously your mineral sands you can, but your market size. So we tend to have small industrial minerals companies. You'll go to Europe, you'll go to North America, there are giants. Okay, and this, I will come to the importance of that later as well. Number of producers. So are you coming in competition? And what are the producers going to do? We've got a limestone producer here. You know, if you open up a quarry next door to Mr. Jonathan Scott, is he just going to sit back and say, oh, well, that's a shame, you know, welcome? Or is he going to say that, you know what, we're going to cut our prices? Availability of substitute minerals. Graphite. You've got artificial graphite. Those two compete like mad. Most of your battery grade graphite at the moment is artificial. Okay. But there are others as well. As a limestone filler, you can substitute talc, you know, porphyroite, kaolins, although limestone normally beats the pants off the rest of them. And often you can supply multiple sort of segments. Okay, so a bentonite, you can, depending on the quality, you can supply, if you've got a very high grade bentonite, you can supply the foundry industry. If you've got a lower grade bentonite and you can dilute your high grade bentonite with some of the guys that are in it, you can supply the pelletizing industry. You can supply the civil engineering game or sealing. All your hazardous waste sites or all your mine sites that have an acid leach, leachate. They have two or three layers: plastic layers, they call it geolump anyway. Geo something liners. Membrane. Well done. Hey. Thanks, Vince. And then it'll have a clay. All right. Now, a clay is a chemical. You have to see it as a chemical beast. And if you've got leachates coming through, they can react with the clay. The hazardous waste site that's on the way to Navitbank. All right. That's you'll see it. It's on the side of the road. It actually looks like a mine dump, but it's actually a hazardous waste site. When they opened it up, they lined it with a local brick clay. It failed. All right. Now I can tell you now for free, there's a lot of sites lined with stuff in South Africa, which if the leachate does get through those first three plastic and geomembranes, can fail. Let's not go into that right now. There's nobody really does tests on that sort of thing at the moment. Okay, so I hope I've given you an idea of some of the complexities. Oh, you can wine. Okay, red wine uses bentonite. And that none of that bentonite, or very little of that bentonite, comes from South Africa. They use weird stuff called mountain blue from Australia, or I don't know. That wine game is a game all on its own. Okay, next one. Please, next slide, sorry. Yes, sales value. It varies on product quality. Now, normally, your classical industrial minerals, your limestones, your kaolins, and bentonites and stuff, do not vary like your metals and other stuff. All right. So over the years, you'll find you can actually forecast prices because they are fairly steady. There, with the new energy minerals, this is very different, as anybody who's been in the lithium game knows, and the graphite game. But you've got to be able to, the common person has to be able to forecast the price, okay, to show the economic value of this project. And that is a terribly tricky business. Okay. All right, you go into what is important. It's a physical, a lot of physical. We talk of chemical properties, but physical properties. So I'll go into a little bit later. Okay, mineralogy is often very important right early on. How easy is it to process? Again, the last one there, technical knowledge of the mineral producer. This is where the Americans and the Europeans, etc., have the one on us. Because they're huge companies, and they can afford to employ several specialists. So, your big French company, Minerals, your big American company, they have technical people that can go and help the customer use their product, or even develop their product better. Okay, they employ several boards of technical experts who can go to the industry, and as an industrial minerals company, that is a big barrier to entry, because it's difficult to get that. Okay. All right. Often prices and not often, prices and specifications are usually established by negotiation between producer and consumer. All right. So, and this is a difficulty because it's direct contact. Anyway, it's confidential, but I've actually sat down with potential customers. That's what I've done. You sit down with them, you face to face with the client, and the customer tells you, yes, he's prepared to accept this. This is why they've done these tests. He gives you the results. He shows you that. They tell you the prices that they're talking about. This is all confidential stuff. You do not put it in your report. You say that you've seen it and you're satisfied that this is okay. Okay, next one, please. This is obvious stuff. You must know how to work out the cost of mining, processing, blah, blah, blah. That's standard. Okay, next slide, please. Okay, excuse me. Yeah, you have to go through the normal stuff when you report. Geology, mapping, geophysical, etc. Analytical, 722. Assay results, including geochemistry, blah, 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 visual estimates, and so on. Now, what is important as well is yes, what do you test your samples for? And often the tests are things like viscosity or abrasiveness, hardness, etc., etc. Color. Color is a subject all on its own. If you ever do get into the white filler business, you need to get a physicist on board, because to understand the full complexities of the color measurement is tricky. So no commercial lab tests these. And then you get, for instance, the paint industry uses a different type of equipment to the paper industry. So you actually have to end up putting your own lab up. You have to build your own lab to test your own equipment, because there's nobody else out there, unless you can persuade a company to come on board, but they will only come on board if it's in their interest to come on board and do the samples for you. And then you've got the issue of what for QC. What do you do for QC? Where do you get external lab results from? There's no labs out there. All right. The competent person's got to work his way through this and satisfy himself. And the QC samples with a lot of these tests, putting blanks in is stupid. Okay, because I mean, if you're measuring color, whiteness, what do you put in as a blank? I mean, a blank piece of coal or something. I mean, you know, okay, so what do you do? What do you do for your standards? Often you have to make an internal standard for yourself. Okay, so assay is good. Okay, metallurgical, you can put processing tests are absolutely key. If you're looking at a limestone or for, let's say, cement or for lime, you have to speak to the company that they're going to be buying the plant from, and they will do tests, and they will start doing tests on a few 100 kilograms, and then they will scale them up. Okay, but you have, so that has to be done. So that is absolutely key. Yeah, next one, please. Okay, mineral resource estimation. Okay, it's a lot of the stuff we talked about before. But here we do talk about the precision of the analytical methods need to be considered. The less precise and standard chemical analyses, blah, 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 often then require composites and bulk sample tests. So yes, you can do your basic test. Let's say a bentonite, you do your swelling index, your cation exchange capacity, you do a few other things. But then you need to do composite tests for the more difficult ones. In terms of standard chemical analyses, recent talk I went to, I mean, you're talking rare earths, and you're talking manganese for the battery game. You're talking going down to parts per billion, or in chemistry. So, you know, chemistry becomes a lot more interesting in that sense. As a competent person, you should always be in contact with the lab concerned, be it an external lab, be it an internal lab. Even if it's an accredited lab, you need to go and talk to the chemists concerned, and understand what they're doing, and then find out when there are problems. I read a paper by an Australian guy recently who said, actually, the chemical labs have got their internal QC so good now, you really don't have to worry about that. I had an experience last year where a lab messed up. Their own internal standards were fine. Our external standards showed a problem. And it ended up, they worked it out internally in the end, took a long time, that they were using the wrong spectrum, and then they were not allowing for the correction with other interfering spectra. So do not depend upon internal lab QC. So that's key. Okay, next one. We've got, okay, here we go. For instance, tests you need to look can be color, grain texture, compressive strength, abrasion resistance, porosity, ability to be polished. That's for aggregates. There's a quarry just north of Pretoria that it's the cyanide, supplies aggregate to the construction industry. Can't be used in roads because it takes a polish. Okay. You could say, well, there's also things like reactivity with cement. The famous one I like to quote is the one in Portugal, where they used the local granite as an aggregate. Years later, it showed up as causing failure, right, within the concrete structures, because they found somehow that silica in that granite was reactive. Okay. Yes, so one needs to look at your final product specifications and your market details and all that, and you need to report on that. Next slide. Okay, really, that is what we've been talking about already. Yeah, you have to incorporate the quality, the whole market aspects with the geology, etc., coming into your modeling. Okay, next slide, thanks. Again, going further, price. Vince down the bottom end of the thing there is an expert on price forecasting. But price forecasting is difficult. Let's just take graphite going forward. You need to forecast what the price is going to do. Now, the Chinese supply the bulk of graphite and they play all Harry with the prices. Sometimes they cut off supply and the price will go up. Other times they need a bit of money, so they pump and the price drops. It's out of your control. So how do you forecast? And there you really need to be, as a competent person, you need to look to use some of the big commercial companies. Roskill, they've got a different name now. The one I like is Benchmark Minerals. But to get them to do a market forecast for your market study costs a few $100,000. Okay, just to subscribe costs you a few $100,000. For a specialist report, it costs even more. But that's what you need to do. All right.
Sorry, Rob, I saw a hand by Skoggs. Andrew Skoggs, you had your hand up briefly. Was that by mistake?
Hi, Andrew.
Is it still raised?
No.
Come up.
Okay.
Yeah.
He was just saying that he can hear and see this, but he can't see himself.
Can you?
That's
I
what
don't
you-
want to see myself, but I just wondered if I'd actually joined the meeting properly.
Yes, you have. We can hear you.
Bad luck.
Oh, I also just got your text, Andrew. All right.
Thanks.
Thanks, Vince.
I haven't used
All right.
Zoom for a long time, so thanks. I'm enjoying it. Thank you very much.
Okay. Listening to me boring everybody to tears. Okay. Location. Now again, I'll talk about location a bit, but you wouldn't think an aggregate quarry. All right. If you take agricultural land, let's change things slightly. In South Africa, up in the Highveld, the quarry needs to be within 100 k's of where the farms are. More than that, it gets too expensive. If you take aggregate, you've got a very similar story. You can't transport aggregate far. But there are exceptions. I don't know if it's still there, but there was huge quarry on the western coast of Scotland that could directly load onto a wharf and export it aggregate to the USA. So again, it depends. In Greece, they've got a bentonite mine, which is on an island, beautiful deep sea. They load directly onto the ship. Makes it easy. Okay, next one. Classifying the mineral resource. Now, this is a difficult one because you have to have the level of confidence in the continuity of the deposit. In other words, a normal confidence level that you would have, but also take into consideration the grades, the thickness. If you've got a limestone, if it's only 2 meters thick, it is viable to mine, and the other physical or chemical properties. And the same goes, so the CP, the confident person, should ensure that all relevant quality factors and other relevant input parameters are included as part of the mineral resource reporting. So the competent person has to have the skills and the knowledge to understand what's going on, to understand the tests, to understand the beneficiation tests, to understand the market tests. And you need to discuss, if you've got a metallurgist or somebody doing that work, you need to understand what he's doing, even if he signs off that section of the report. I prefer you go and see the customers, or at least have some sort of discussion with them. You go to the labs, you understand what they're doing. Ideally, you should have input into what they need to do. And what I have helped people put together labs and stuff like that, because that's what you have to do. And you have to verify that they're doing the work properly. You have to work out the quality tests. Okay. One big criticism I have of our section is we talk of QA, QC as if it's the same thing. It's not. So QC is the direct sample testing. Okay, QA is the overall procedures for everything, which, to be honest with you, whereas in the industry we are way behind on that sort of thing. But let's go forward. Next one, please. Okay, mineral reserve. Again, gets more important, but I have used debates here about when you can call something an indicated resource or a measured resource, even before it gets to the reserves. And you say, look, we need to know the market, considerations, we need to blah, blah, blah. And a lot of clients will tell you, no, that's when you get to the reserve stage. Okay, we don't worry about that now, that's reserve stage. So you have the endless backwards and forward, but certainly at the mineral reserve estimation, the bottom point under 9.1, availability in the offtake agreement, letter of content, contract in hand, a marketing plan supported by an independent market analysis. Ideally, you should have a sales contract, ideally, at the reserve stage. Letters of intent, frankly, to my mind, aren't adequate. You can have your marketing plan. Now, who's done the marketing plan? You get marketing experts who will give you the stuff, and I've read the stuff. I've read these things, and they don't have a clue. It's a general discussion about graphite is used in refractories, and blah blah blah. I managed to get some tonnage out of the government stats and stuff. But does the person doing the marketing plan know what they're talking about? And you've got to make sure that they do. If they don't, you don't accept it. I've seen one big project where the very first thing they did was a marketing plan, even before they did any, drilling. I mean, the marketing plan was a joke. They spent a lot of money on it. Okay. Yeah. Industrial mineral deposits should incorporate rigorous research and assessment of all quality factors, including those specific to the commodity. Next slide, please. I think we've been through this. The CP should clearly state what additional information is required in order to increase confidence. So the confident person has to, again, have the skills and knowledge to say to the clients concerned, extra work is required, and he needs to stipulate what that extra work is. Next one, please. Okay, you can get published specs to start off with. The ASTM is a very good one. Have to buy them. For foundries, your AFS, the local foundry society, they have their own publications. I'm involved in reviewing one they're doing on chromite sands at the moment. So you can use the local sort of institutions, etc., etc. Because often, like a foundry, they will base their requirements on those sort of guidelines, and but you can fall back on the AFS, ASTM. The problem with ASTM or some of these is or API. API is the one I'm going to talk about. That's American Petroleum Institute. If you take bentonite, those specs are designed for the Wyoming bentonite, which is the famous bentonite. No other bentonite in the world can make those specifications. This is one of those things. Doesn't mean it's not suitable, but that's the way it pans out. All right. So if you think you're going to test your bentonite against API specs, okay, Andrew can actually do it. He's one of the few guys who has a lab set up to do it. But frankly, Andrew, am I talking nonsense here? But my own personal experiences, you can't really make the full specification. No. All right. Must have gone. Okay. Now this may necessitate a pilot plant test or start of production. And I was telling Jonathan earlier about, there's a classic case of this. Well, I was involved in one a couple of years back, where the company, for a year, the drilling program was short. They didn't had a technical expert build a plant. He built the lab. He built the pilot plant. It took him a year to go through the whole sort of procedure. Recently, up in Malawi, a graphite rutile project, they excavated probably a few 100,000 tons to do a bulk tires test work, and they had to rehabilitate it. They couldn't even leave the pit as a sort of starting pit for the mine. They had to close it all up. We had to do that, and I was on a project which I was financially involved in, where we gave 500 tons for free to a ferrochrome company. That's how, because to get them to do the test, you had to give them to them for free. Then we had to close it all up. Okay? So you go to all the expense. It's a very expensive exercise. Okay, next one. Yeah. Okay. A little mention here. Some industrial minerals companies are just not the size, or they don't have the margin to go for feasibility studies and all this sort of stuff. Sand is a classical one, right? Building sand, let's say foundry sand, whatever. Those are small. So what you end up there doing is basically you open the mine up and you get it going and you show that they can supply, etc., etc. Which a risk the owners take. But again, if you are doing a competent person's report on it, that's the way you need to report. I'm running out of time. Okay, let's go forth. Next slide, please. Sorry. I think this we've covered most of this. So you can go forth. Okay, there's a specific section for dimension study. All right, but I'm not going to go into this in great detail because basically a lot of it is covered by what I said before. You need to understand what the market requires. The one issue to be aware of in dimension stone is that the industry is controlled by the Italians. We tried to start up black granite companies with Keely Granite. Anglo started up a big company. They all ended up selling off to the Italians. A friend of mine did the landscaping for Victoria, where they had to reopen some of the old quarries for the old paving and stuff like this. And the Italian company concerned flew him. They have an annual conference. It's in the same place in Italy. They were met at the airport by Ferraris. All right. Yeah. They source from all over the world. So if you think you can walk in and start your own little dimension stone thing, It's a big barrier to entry. It's a big barrier. That's a general. But yes, there's a specific section. Please read it for dimension stuff. Next one. Okay, here's the table 1, which we have been through, but the key ones are 3. Okay. 4, 5, 6, 7. Okay. This is a very good table. That should start to be the basis of your reference. Okay, let's go to the appendices, please. First, next slide. Okay, we just again you can read this. It's a list of minerals and basic industries on the right-hand side. Next one, please. This is put in by Andrew Manley. These are some of the deleterious components that you need to be aware of, but these are just examples. Okay, so it's a good reference table to start off with. For instance, looking at ball clay, iron, quartz, both negative, andalusite, negative, iron, titanium, silica, potassium, sodium, minerals, garnet, strawlite, magnetite. Okay, how softened? Yes, you mine your weathered profile. Okay. Next slide, please. Okay, this is in 3 sections. Here we broke as a guide different industries and the minerals used in them, examples of the processing methods, examples of the test methods, and general comments. And in some of those comments, we do mention some specifications where relevant. And that's where, for instance, agricultural limestone, transport distance for customer typically needs to be less than 100 k's. All right. Construction at the bottom, right-hand side. Specifications vary between governmental agencies and industrial users. So often they're set for individual projects. Next slide, please. That's a continuation. We've got energy, minerals, for instance. But these days, graphite, if you're going to supply the battery market, i.e. the guys who make spherical graphite, which is really the Chinese. Okay, Syrah has set up a plant in the US. It's the only other one in the West. But basically, X mine needs to be above 95% carbon. For your refractory industry, and that it can be less. Okay. The very lowest is about 80. But there's all sorts of other specifications you need to get into that sort of game. All right. The tricky bit with the graphite for the battery market is it needs to be less than 150 micron, but it needs to be greater than 75 micron. And your minus 75 micron graphite, you basically can't sell. It really is. It's a very difficult material to sell. So you need to produce a very fine size range, which is not easy. Okay, yeah, I put something like foundry. You can see American foundry industry used for size and other specification, etc. Okay, next table. Okay, this is the last one. Right on the bottom there, welding. Welding uses a multitude of minerals. Absolute multitude. If you go to a welding factory, you'll be staggered by the variety of minerals that they have. But they really have to buy commercial grades because they buy so little. All right. All right, refractories. If you look at refractory bauxite, generally we've given a general maximum 2% iron, calcine basis, alumina 80%, 86% plus, etc., etc. So there are some guidelines in there as to what to look for. And everybody's now moved, so I'm finished.
Great. No, thank you, Rabbi. Yeah, I'll let you go on because I always learn quite a lot with some of those examples, considerations and nuances that you had. So thank you very much for that. In the interest of time, it's supposed to be a Q&A, but our breakfast is getting cold as well. So I'll allow one question online if there is. If someone whoever's still remaining, if there's a question for the subcommittee, all this good work that's been done. Any questions on that end, Google? No hands up?
Maybe one comment. It's Martin Ritz from SRK. In a previous life, I worked on a fluorspar operation in Namibia, and you cannot emphasize the deleterious elements and the contaminants, how they threaten the salability of your product. So I'm glad you brought it in at the end. I was wondering when you were going to get to that, because that's actually crucial in, it's not the quality of the ore, we had a problem with phosphorus, and there were certain shipments we couldn't actually sell because of that, because of the amount of phosphate in the actual product that we had. So yeah.
Thanks, good point. In the guidelines itself, it is more stressed, than just in that one table. But yes, that is a key aspect.
It is. It's very important.
Yeah.
All right. Last chance. Anyone online? Thank you for that. Anyone online? Virtually? Sorry, let me not obscure Peter, who was quite vital in this, sitting next to me, the subcommittee. Ali, go for it. Right, you are allowed to talk now.
Yeah, okay. Sorry, I have a question regarding the marketing, mostly for example, for dimensional stones. Should the competent person be follow the marketing individually, or should rely on some marketing reports that exist, for example? Because for competent person to follow the marketing individually is a very difficult one, and maybe is a time consumable to follow the marketing, especially for example, I'm talking of some dimensional stones that it's a very difficult for a competent person to follow directly. What's the recommendation or situation for competent person if they cannot do directly the marketing and should be rely on some marketing report existing somehow?
In terms of, okay, thanks for the question. In terms of dimension stone, my own experience is you essentially have to open up the quarry. You have to actually do the bulk sampling we talked about. You actually have to open it up, take blocks out, get them split, etc. So you pretty much have to start up production. So it's not a simple matter of, for instance, blasting a small pit in or drilling holes or something and then coming up with a marketing plan. You really need to open it up and actually start selling and show that you can sell the blocks that you're producing.
Is it because I ask this because the marketing is a very variable and time to time may change. For example, for a life of mine reserve reporting, the marketing may change time to time, and too many variables coming in to change the market. For agricultural material also the same. So how we can add this marketing when we report a reserve? If we know it is not standing at the same time, for example, marketing of 2 years ago is a completely different maybe with the next year or the following year.
Yeah, this is a complexity, and to be honest with you, Annie, for many industrial minerals, it is really only companies that are in the business that can really do the prospecting, because they have that knowledge. And to be blunt, that is very often the case, that it is so complex that you really need, for instance, a cement company to prospect for cement limestone, because they've got that knowledge. It's not easy knowledge to come by. You can't go to industrial minerals suppliers and ask them questions. They won't tell you the truth. Okay. Bit like diamonds, as far as that goes.
Andrew Scoggs, you've got a response to that too. You've got your hand up. Unmute yourself, please. Oh, Togo can unmute you. Open your mouth. Andrew, can you unmute yourself?
Can you hear me now?
Yes, we can. Go for it.
Thanks. Firstly, Rob, just that question about the bentonite. Some bentonites other than Wyoming can meet the API specs, but you need to treat them chemically, as you know, with soda ash or polymers. And just in terms of the reserve question or resources, from my perspective, I'd say the most important thing when reporting a resource, even if forecasts are wrong in the end, you have to be very clear about the baseline that you're using at the time of the report. It's much like gold, isn't it? I mean, the gold price varies, and so reserves change according to the gold price. Does that sound... You know, you'd have to make assumptions that you could sell the product for a certain amount of money. And of course, it may change, but that's all material. And I think the CP needs to be transparent about all that.
Yeah, thanks. Good comment.
Dimension stone's the same. You know, it's a sort of fashion item, actually, in a way. You know, it changes according to fashions.
Well, also fashion, but look, I know what happens to architects. Look, well, it'll be done online now, but in the day, the thing with the Italians, they went with a huge book, opened it up, page after page of different colors and textures, and the architect would choose what he wanted. He didn't care where it came from or whatever. That was the color, that's the texture that he wanted or she wanted. I think
black granite was very popular at one time. It still is. Marble's varied, and it depends geographically too, doesn't it? You know, marble's very used a lot in the Mediterranean area.
Well, yes, that's a classic area. That's a classic area. Yeah.
Anyway, thank you very much for your presentation. I really appreciated it.
Thank you. You may have missed the beginning, but thanks for the effort that you put in.
It's a pleasure, and it was great to be involved.
Yeah. No, thanks for joining us at your time.
Peter's got a question.
Oh, yeah. Can I offer a couple of examples that I've faced during many years of working with industrial minerals? The weight of this piece of paper, half of the weight is calcium carbonate inside this wood pulp. And I work for a company called Edwala that owns the Portchepston limestone mine called Umzimkhulu Lime, Edwala Lime. And it is specialized in supplying the paint and paper industry. All this white paint you see above your head has got that lime in it. And even this plastic of the table has got lime in it. And many, many years ago, about 40 years ago, we had the problem of marketing, and we discovered there was a very large white limestone company called Omya, O-M-Y-A. And its other name is Plus-Stafa. It's a Swiss company. And they've got a huge laboratory with full-scale paper mills and paint preparing equipment in it at a place called Oftringen in Switzerland. And we were shown how to go to them through the paper industry. They said, we won't take your white limestone, even if it's the best from South Africa, we'll import rather, unless you get a signed off stamp or approval from Oftringen University. They've got about 20 PhD guys there running the show. So they're the world top operators, and they've got limestone quarries all over the world supplying specifically the paper industry. So we took our samples to them and they prepared them and they made paper with them and so on. And then once we've got all those reports, we then went along to a customer. So that's what Oftringen says. that they approve it. And you can actually go to sleep at night after that because you know the thing is correct. So you don't want to have pitfalls when you start going into this game. An example of a pitfall is that big plate of glass there. All comes from one flat glass factory in the whole of Africa, and that is in Springs, Pilkington Glass Company.
Well, it used to be Pilkington, is that?
Yeah, they've changed now, but they had a problem many years ago. And it's a uniquely South African problem, nothing to do with the deposit. It is all to do with South Africa is a huge producer of chrome. So every railway truck or road truck had at some time in its life carried a load of chrome. And the problem with chrome, it won't melt in the glass tank, the huge big tank of glass. That little chrome grain will go right through, come out the other end up in kilometer long flat glass sheet that's coming out of the plant. It runs for 10 years, continuously 365 days a year. They never stop. It just goes on. It does not stop. And if a sheet of that glass ends up at a factory that makes the bed glass for car windows, for example, that little chrome grain hasn't melted. It's still in the glass. And you go over a bump in your car and suddenly the glass shatters for unknown reason. So that is a pitfall people aren't aware of. It's nothing to do with the deposit or the process or anything else. It's all about
Transport.
Contamination from the transport system. And they actually set up a lab at the gate of Pilkington's years ago where they tested samples coming in. And they talked about nothing more than 1 part per billion of chrome in your product. If it got that, send the trucks back. We don't want them.
No, thanks for those gems and those pitfalls as well. We will continue here while we're having breakfast, those who came in person. But thanks to those who attended virtually. And continuing on your CPD, excuse the pun, continuing professional development. Thanks to those who attend in person, who get the breakfast and the copies. I'll chat to Rob and Nicole around sending to the delegates, the virtual ones, a digital copy, but I'll have to check that. And then, thanks to the committee again, once again, Peter, Rob, Nicole, Vince, and various others, out there, Andrew Scoggs, as I said, Andrew Mack, and others I haven't mentioned. So thanks for all their hard work. And with that, we will close. We will continue having some of these interesting stories here. And thank you and enjoy your day further, everyone.
Can I just show a couple of small things?
Well,
You'll show us here. We can close there. Yeah, thanks. Ciao.